In the previous class, we did VPN for one of the customer, isn't it? Let me check. I remember we did it. R1 DC routes, show IP route. Yeah, we have learned routes. See, route to reach 2222 is available. And I think I was tracing for you like this. With the source 11111, we were seeing the VPN label as well as the transport label. And that is where we stopped. Meanwhile, let me clear these things. We did not use these infos. We were using different one. So I'm bringing this down here. This VRF also we have not used. We use something of our own. Okay, see, it is having a VPN label and the transport label. The transport label will get removed when packet goes from 5 to 6 because it's PHP for transport. But VPN label gets removed only on router 6. So 23 will remain till, see, 23 is still there. When the packet goes to router 6, you still have that VPN label because VPN ends on router 6, which router 5 don't know. VPN is between R3 and R6. R5 cannot do PHP for VPN. Yeah. So it is R6 the one which removes the VPN label and sending the packet to router 2 without any label because we don't have MPLS, we don't have VPN in between R6 and R6 and R2. Right, so this 23, who gives this label? It is R6. R6 provides the label for R2. I can show you that. You go to router 6. And if you see here, show MPLS interfaces will not show any VPN, but we do have VPN here. Show MPLS forwarding, it will show you VPN, you see. For 22222, a label number 23. Yeah. And there is no outgoing label because on this outside interface, there is no MPLS. So there is a big difference between pop label and no label. No label is, there is no MPLS on that direction, G3/0. Pop label is, I do have MPLS, but because of PHP, I'm popping off. For example, 10.45, R6 will pop because 10.45, router 5 is the ultimate router. R6 need to do PHP on F0/0. We do have MPLS on F0/0. Right, so we have VPN marking very clearly in the bracket, VPN. Show MPLS forwarding table for 2.2.2.2/32. Okay, you cannot put 32, just put 32, not slash. Show forwarding table for 232. Local label, outgoing label, why it is not showing here. But we see it here. Now router 6 has got label. Now I would like to see show IPBGP VPN v4 unicast. And we got a network 11111. I want to know about this network. So I'm saying show IPBGP VPN v4 1.1.101. All means all VRF, in which I want to see 1111. What we see is this network, there is one path, and that one path is the best path. And that one path is advertised by 3333. If you see our diagram, 3333 is the other end of the tunnel. So router 3 only has given this route. We all know that it is IBGB. And you see the route target value. Right? And it is using this route target, it has imported it. BGP routing table enters 2626.2. Who is this 2626.2? Okay, here. 2626.2. That's the neighbor to which this is given. .2 colon. No, sorry. This is actually the route distinguisher that we gave. You should not get confused with. That's why I don't use this type of number. If you see here, show IPVRF route distinguisher, we gave this. So it's a route distinguisher colon 11111. So it says that this route is for Tinku routing table. So this is Tinku. This is 1 colon 1 1.1.1.1. This 1 colon 1 is the route target value. Imported path from. See? Show IPVRF detail. You can see route target is 1 colon 1 import value. That is what you saw in the above. Route distinguisher, sorry, route target and the prefix is appended to it. And you see the label? Label number is 23. VPN label. So now the packet needs to go to 3333. Now, if you check the BGP table, show IPBGP for 3333, there is no BGP because it's local. So show IP route 3333, it is via OSPF. And if you check the CEF table, show IP CEF 3333, Then you see the outgoing label as 20. This is the transport label. 20 is transport label. And this one, which we saw here, 23 is a VPN label. Next. If you see, here I have a subnet 1111 and the same subnet 1111 is also here. So both Binku and Tinku has got the same network. And both are going to use one VPN. One BGP provided tunnel. But inside the tunnel, they are not one. How? I just showed you this 1111 is prepended with 1111 is prepended with the route target value. So when you give different route target for this customer, that will be prepended. So that is different from this one. For example, if I give 2:2 for this customer, Binku, then it will be 2:2 11111. So the 64-bit value is what taken, not just 32-bit. IP address is 32-bit. Route target is another 32-bit. 32, 32, 64. So it is going to see 64-bit address. It's not 32-bit prefix. It's 64-bit. That is how they are differentiated. So there is no conflict in between. There is no conflict within. If two customers have got same subnet, there will not be any conflict within this tunnel. They know whose 1111 it is. See, we have not done VPN between R7. Sorry, we have not done the eBGP between R7 and R3, R8 and R6. I'm going to do it now, and then I'll show you tracing the route. I'll show you tracing the route. When I trace route from router 8, the packet will go to only this 11111. When I trace route from 2, it will go to only this 1111 because the route target is going to make the difference. Now, to do that, first of all, I would like to go and check whether R7 is ready with BGP. Router 7 is totally, completely new, empty. It's completely empty. Likewise, router 8, empty. We need to configure this both. Enable config T, host name R7 Bingo. Interface loopback 0. I'm going to put two loopbacks. One is 777. The other one is interface loopback 1. And now we are going to advertise this in BGP router BGP 700. neighbor is 73, 73, 73.3. Remote areas will be 10. I would like to advertise these networks. Done. Now we will now get into router 3. In router 3 we got one VRF already. Show IP VRF. Now we need to create another VRF. I'm going to say IP VRF Bink left. Route distinguisher 1:1 is already given to Tinku. So I am here giving route distinguisher 2:2. Route target I'm going to say 2:2. Now I'll assign the interface G4/0 under this VRF Binku, the new routing table. Interface G4/0, no shut, IP address 73.73.73.1. Oh, I made a mistake. What mistake can you say? Can anyone say what mistake I have done? I went to the interface and then I have given IP address. What is the mistake? Yeah, we need to allocate the interface to the VRF, then give the IP. IP VRF forwarding for Binku left. And then I'm going to put the IP address again. Done. Show IP VRF. I can see Binku L, route distinguisher 2:2, and the interface is G0/4. When I say detail, I can see this is Tinku. We want Binku. Binku, this ID will be automatically given, VRF ID. We no need to give. First VRF that you create will have 1. The second VRF that you create will be 2. And this is the route target we have configured already. Done. Now show IP route VRF Bingo. So this route, I'll go and check the router 7. I don't know whether I configured G3/0. 7. Show IP interface brief. It's not configured. IP address is 73. Okay, so we got 73 and the two loopbacks, 111 and 777. Now, what is next? On R3, we need to enable VRF aware BGP. not simple BGP, VRF over BGP. So we need to go to router 3 and say we have to say router BGP 10 IPVRF address family IPv4 VRF bingo. Here only I need to say neighbor 73.7. Remote AS is 700. Now we will be seeing neighbor coming up via the VRF ping L. If it is not coming for a long time, I can fix it by troubleshooting. I'm saying ping using the VRF binku -L this address. Huh, it is pinging, but I'm not able to form neighbor. Why? Show IP show IP BGP VPN v4 unicast VPN v4 all summary. It shows idle, but when I ping it pings. Show run section router BGP. Okay, we have an address family called Binku L, correct? Neighbor 73.73.73.7. Remote is 700. The activate command we did not give, it will come automatically. So there is no problem in this side. I think there is something issue on road 1. Some issue on road 1. Show run section. (73.73.03). Ping and see this. Okay, on router 3 I have given wrong address. Show run interface G4/0. Aha, I've given 1. I want it to be 3. Now we will see neighbor coming up. Now we are going to verify. Show IP route VRF Pinku. We learned 2 routes. If you go 6, router 6, you will have a surprise there. But no, we have to first have VRF for this Binku. Then I'll show you the surprise. IP VRF Binku in the right. Route distinction can be anything. I gave 2:2. Here I'm giving 22:22. But route target should match. I gave 2:2 for both import and export there. And then I'll go under interface G4/0. No shut. IPVRF forwarding. Binku -R. IP address will be 86.86.86.6. And then we need to do BGP. Router BGP 10. Address family IPv4 VRF Binku -R. Under this, I have to say you got a neighbor which is 86.86.86.8. Remote ASS 800. Alright, so we'll now go and get this things verified properly. What I want to show you is in the routing table of Binku, you will see routes from router 7. In routing table of Binku, not in Tinku, Binku. Show IP route VRF Binku right. You see, you have already learned the routes from the remote site. And this is pointing towards 333, okay? And if I check Tinku, that is also pointing towards 333. Listen carefully. This is also pointing towards 333. That is Binku. And this is also pointing towards 333. But they both don't have same labels. I want to show you that. They both don't have same labels. You see. Show IP safe. Sorry. Show IP, show MPLS forwarding table. Now you need to check this on router 3. Show IP, show MPLS forwarding. You see, you got two 1.1.1.1. One is with the next stop router 7, for which the label is 17. The VPN label is 17. You got another 1.1.1.1 for which the next stop is router 1. Label is 23. Yeah? Two different labels. Even though the network appears to be same, but it is not same. Why they are not same? Because the route target that is appended, sorry, prepended to the prefix is different. That I would like to show you. On R6 when I check, show IP BGP VPN v4. All. You see, there are two 1111, but the route distinguisher is different. This is the route distinguisher for here it is, Binku and Tinku here. This is the route distinguisher for Binku, which I just created. This is the route distinguisher for Tinku, but route distinguisher is not the one which is going to be in VPN. It's the route target. So let's say first I'll show you Binku. And you see the route target. Route target is what getting prepended. It is 2222 for Binku. If I change that to Tinku, it will be 1:1. It is 1:1. So if you see the whole number, it is not the same. The whole thing, like whole 64-bit. This is here. This is different. This is different. They don't look same. Maybe this 32 looks same. I agree, but the prepended value is not same. That keeps this customer's route separate. They're not getting mixed. What else next? Okay, now we need to form neighbor between R6 and R8. R8 is still not configured. Let's go to R8. Now if you see, we got the routes. Show IP route, you see we got 1111. When I trace route this 1111 from here, trace route with the source. It will go to router 7. At the same time, I'm also going to trace route from router 2. That same 1111, but it is not the same. The prefix is same, but not to the same customer. Trace route 11111. So in both the customer, what is this? Oh, I think there is some issue. R7 has not learned 777. Sorry, 888. Yeah, it has not learned 888 for some reason. Why? There is no prefix learn. So there is something wrong with. I don't see. I don't see 88888 coming here. So router 8 itself may have some problem. Router 6 did not receive the route. Show IP route VRF bingo R. We don't have 888. This is the problem. Router 8 is not advertising for some reason. We need to check why. Just need to stop. Then only I can check. Okay, meanwhile, let's see this one 7. I was tracing from 7, no? Sorry, 2, from 2. See, this has gone straight to router 1. 3 and 1. This trace will not stop. I think it will go to 30 hops, 30 times something. It is like that. It will time out. Let us fix this first of all. On router 8, show IP BGP. We want to check whether it is not advertised. Show RAN section router BGP. Not advertised. My fault. Now network is 8.8.8.8. Mask is 255. Okay. Now I'll be able to trace route from here once the route reaches R7. R7 has learned one prefix. 888 is seen here. Now trace route. And you will see this one going to router 7 with a different label, not 23. The previous one, when I was tracing route, I was seeing on router 2, 23 was the VPN label for 111. But now definitely it should be different VPN. For each customer, there will be different VPN number, label number. Okay, which one is the VPN label here? There, the VPN label was 23 here. For 11111, which one is the VPN label? Correct. 17. See, when it goes to router 4, even the transport label is also 17, but it is okay. It won't conflict. Now you see from 3 it will go to 7, not 1. Because we saw the route target can keep them separate. See, they don't get mixed. Even though the subnets are same with multiple customers, the prefixes are same with multiple customers, they don't conflict. That's what we learned from here. Right. So I